Last session. We made it. So we're standing between you and beer probably. And so let's try to have some fun. All right, they're shutting the doors back there. My name's Shannon Snowden. I'm Senior Technical Architect with our Tech Alliances team. One of the alliances we have is with AWS. And this is...
And I'm Amy Mitchell. I'm a product manager on handling our platforms as well as scalability and performance.
So what we wanted to do in this session was not really give you death by PowerPoint on what is AWS and how Zerto works with it. Hopefully by now you are aware of that. What we wanted to focus on this session was two things. We'll do a brief overview of the solution in case you're not aware of how we work with it. But then section 2, there's going to be the bulk of this session. And the reason why we're doing this, Amy and I are working together to have a more prescriptive way of even deploying to public cloud. So this is for AWS, but a lot of this also applies to Azure as well. So yes. It's a sequence. It's how you go through it, very systematic fashion. So you have much better success in the public cloud. So we're going to go through the things to look for and how to plan and then deploy, how to measure it, and to have a successful experience going to the cloud. So let's go through the architecture. Who's not seen this slide? All right. How many's running Zerto on AWS already? We have a few? Okay, good. What we're showing here is on the production site to the left is a standard vCenter, vSphere site with replication through a VPN to VPC to AWS, and then we go into our Zerto cloud appliance, which is an M3 X large by default. And then our replication goes to AWS, and the VMs are actually stored in S3 buckets. So hopefully we're up to speed together on this, because this is the concept of how we're doing it once it's in place, and then kind of the rest of the presentation is about how to get it in place. So we have the ZVM on that site. Let me populate this up fully. Now, one of the things that came out in the last version was coming out of AWS back to on-prem. Who didn't know that? See, we got us.
Is anyone doing out of AWS?
Yeah, is anybody? Okay. The process is when we're in AWS and we do a failover or a fail out or a move operation to on-prem, there's several things happening under the hood because of the way that Zerto works with AWS. So the first thing is this little thing called a ZASA. And so what's a ZASA, Amy?
Well, it's our snapshot satellite. So we are picking up snapshots. That's how we get the stuff out of AWS. So these are some new processes that you will see on AWS when you go out of AWS. They're only spun up for the out of AWS time. They kill themselves when they're done.
Yeah, it's very morbid. So there's ZSATs. So the ZASA sort of controls the ZSATs, right? Which are the satellites. Yes. And these are just helper instances to help get the replication back to on-prem, down to on-prem. Once it's done, these things, as Amy said, go away. So they sort of burst out, do their job, and then they, what'd you say? Kill themselves?
They kill themselves, yeah.
Yeah, so. All right, so of course with AWS you've got data centers everywhere and regions, and it kind of supports that whole global multi-cloud solution that Zerto gives you, and you can kind of put it wherever you need to, and this is another way of thinking of that cloud diversity of on-prem, colo, to hybrid, to AWS, to Azure, wherever you want to go, we allow you to do it. And then, of course, there's different use cases. So you want to migrate, you want to be able to test before you go on to public cloud, obviously. And then you're ready to just know that you're good to go before you cut it over. and you're with the one-to-many feature, for example, you could do the on-prem protection, but then start testing into the cloud. So I'm able to do migration testing or failover testing to AWS, get what information I need to know, how long it's going to be as far as the move operation, then I'm ready to go.
Is anyone here doing migration, or are the ones that are using AWS, are you using it for protection? You're a migration?
Both. Yeah.
Great.
Great.
Great. Both. Great.
Sure. We could add. Okay. What's the ability to migrate most OSs without modification?
Was it Linux?
Yeah.
That
would go under
certain
the
versions of Linux that you need, or were you needed the most versions? Okay.
Right. It's
Right. Right.
I guess we should have had a microphone for that, right? Oops.
Yeah. So.
They're recording this session.
Yeah.
So let's get into the section 2, because this is where we want to spend most of our time. And this is planning for getting a solution built to go to AWS. So I'm going to hand the clicker to you, Amy, because
Yeah.
Amy's going to drive
So-
most of this.
So we've learned from some of our customers where there's a large-scale migration or data protection to the cloud. We're getting a lot of questions about how many instances should I plan for? What would be my business case? How many ZCA instances should I have? What size should I get? And there's a lot of variability here. So what we've been working on is coming up with a methodology so that you can arrive at those answers, because it's not yet, there's just so many moving pieces that we don't have really a cookbook, but we do have a recipe for you. So as a little bit of background, and probably everyone here knows this, but I wanted to be sure we're all on the same page before getting into the next bit of this. There are some differences between our on-premise VMware on-site to on-site versus doing on-site to the cloud. So everyone's familiar with, we've got the on-site here on the left side of the screen, and then on the right side is either another site with like VMware or Hyper-V, and then down at the bottom we have a cloud case. So we're happily replicating either to another site, and it's ready to handle a failover. You're doing successful failover tests. Same story if you're in AWS. So if you're on-premise to on-premise protection, you would lose a VM. Then the replication stops. Then we create the VM over on the recovery site. We move the mirror disk over to that VM, and then the journal is then promoted into the virtual disk. So that's simple. Similar process on the cloud side. You would lose a VM. You'd stop the replication. We'd automatically create the VM. But there's a little bit of a difference here. We have to promote the mirror disk from S3 over to EBS. That does take time depending on how big your journal is. Typically people are doing smaller journals than what we're doing on-site. And then of course the mirror disk and the journal goes away. So I want to make you aware of some of these differences because that does have an impact on RTO. So just to sum up some of the, Radu, yeah. Let's repeat his question. If you have...
Yeah, see. Hang on just a second.
Thank you. Yeah. I don't think the guys in the back can hear you.
I'm sorry. We were looking for some similar scenarios, not Zerto related, for the cloud. And there's some AWS instances with a lot of IOPS and super fast disks. Do you think, like IT extra large or something like this, do you think it'll help in this case because this seems to be very IO intensive, or the problem is just getting the data out of S3 bucket?
It's getting it out of S3. We do support about 4 different instance sizes, which I cover on the last slide. We haven't tried any of the I-series ones, though.
Thanks.
And I'm not that familiar with their specifications. I'd have to check if it's something that we support.
Up to 80,000 IOPS.
Well, we need to have a certain number of CPUs in memory as well.
Up to 64.
Okay. We haven't tried any of the I-series ones.
Yeah.
So.
Okay, thanks.
Okay, to sum up some of these differences on what we've observed on the initial synchronization, oftentimes when you're on-premise, you're on your own LAN doing the initial synchronization, and then on the cloud, you're typically going over a WAN. Sometimes the WAN could have high latency or lower bandwidth than what we're used to on a LAN. So the initial sync could take a little bit longer. A key point we're going to talk about is that you need to wait for the initial sync to finish before you go launching into a failover test or a failover. It's due to the time difference, it works better to let the initial sync finish. On steady state replication, it's typically paced by the 2 VRAs and by the networking bandwidth. When we're going to the cloud, the steady state replication has ZCA and the VRA, and then again you've got the WAN bandwidth for the steady state replication, which could be different than a LAN. The RTO, because of the promotion time from S3 to EC2, is going to affect your RTO. So the best way to get around that is a smaller journal, also having the smallest amount of VMs that you can get away with in your VPGs.
So 2 things on that. So you talk about a smaller journal, so that's the reason why we recommend the starting with an hour journal to get going on the initial syncs and the initial testing and things, because it goes back to what you talked about earlier, was the promotion process. So it's promoting all those changes in the journal. So if your journal's really long, it could, with a lot of changes, it could take quite a bit longer. Now you also talk about fewer VMs in a VPG. And so let's crack that open a little bit and talk about why that's a good idea.
Yeah, because the more VMs that are in a VPG, if we go back a slide, each one of those VMs is potentially having multiple volumes with it, which would need multiple mirrors. And so we're trying to be optimized so that it's everything around the consistency group that you need to keep consistent, so that we don't have multiple mirrors to be promoted.
So would it also, if, let's say there's 3 VMs in a VPG, if 2 of them have a lot less I/O and one has a lot, it would still impact like the whole VPG from completing, correct?
Right.
So that helps you also isolate which one's causing the long pole in the tent, basically.
Right. Then on failover handling, like we saw in the picture, it's a lot shorter. We don't have to copy anything. The disks are made available immediately on site, whereas in the cloud, we have to let the promotion finish. On the failback, another key thing to keep in mind is coming out of the cloud, we don't have a way to keep multiple volumes and multiple VMs synchronized. So you want to be careful about what you select for the
So like a move
consistency group.
operation would be recommended.
And on the move operation, if you do have multiple volumes and VMs, that's a great point, Shannon. you would need to shut down the VM to keep that consistency, and then fail it back, and then fire it up.
Again, it all has to do with working within the confines of a public cloud and the mechanisms that we have to use in order to get that data that you need to be able to fail it back out, the changes. It just is the reality of working in the AWS ecosystem.
So moving on, the recipe book that we're talking about today is, first step is planning. Have an architecture in mind of the involved sites, the networking, and the AWS cloud where you're going to connect to. Second thing, and this is very typical to on-site as well, evaluate your workloads and your VMs, storage. The write ratios are especially critical because what's getting replicated are the writes. So if you know the write ratios, you know your IOPS, or you know your block size so you can back into megabytes per second. That's very helpful. Then you would map out VPGs. By VPGs, you would be thinking about the VMs on site and then where they connect to on the ZCAs and the AWS side. Next, update your architecture picture so you can actually map out and be sure that you're not landing a whole bunch of VPGs on the same ZCA instance, because there are limits on AWS, depending on your instance size, for the megabytes per second throughput that instance can absorb. So what we're trying to advocate here is sort of like measure twice before you cut your wood. Just be sure you've got a good picture in place, that there's a lot of moving pieces. You don't want to overstretch anything along the way.
Okay.
The next step would be, once you kind of get it mapped out, pick one VPG possibly, or a set of VPGs that represent VMs and that you are comfortable with, and do that one first. Monitor for the initial sync to finish, then monitor the steady state replication so you get a nice baseline of what the bandwidth is needed for steady state replication. Then do your failover test. After you're sure you've got a baseline, run a failover test. Then you can actually be confident that when those VMs fail, you know what they're going to behave like if they restore up on AWS.
So what you're seeing here is a very deliberate process, unlike what you would probably do on-prem. So it's heavy planning, and then do your first set, as Amy said, let it get synced, and then before you start trying to test, make sure it's fully synced. And then compare what you've planned in your worksheet versus what you're seeing for real, because those workloads are dynamic. And
right.
So it gives you more data in order to adjust to do the next sets of VPGs. So it's just a systematic discover, implement, discover, implement, discover, implement, and you'll be much more successful that way. Any public cloud, Azure or AWS, is a lot less forgiving than on-premises, where you can just create VPGs and
high bandwidth.
Yeah, and high bandwidth.
Yeah. Okay, so we're going to show you some worksheets that Shannon and I have actually used recently with customers that are doing major deployments into public cloud. We wanted to share these examples with their personal information removed, so you can have some templates to try this out. So on the first step is just identifying your sites, your networking, and which regions of AWS do you want to connect your sites into. The one that usually takes the most effort is evaluating your VMs and your workloads. This is an example. This was actually in an Excel spreadsheet. It's a lot easier in Excel because you'll notice on here the megabytes per second is a blank column because I didn't want to do the calculations and hand translate them into here, but you can easily do that in Excel by dividing out the block size with the IOPS rate. And you will see on both AWS and Azure, there are instance limits. And if you have small blocks, the IOPS limits will look fine. But if you have larger blocks, you'll start butting up on the megabytes per second limit first for the cloud instance. So a little bit of characterization of the workload. Oftentimes, if you're a cloud service provider, you're dealing with your own customers, they don't know a lot about the workloads. If you say, oh, tell me what your read-write ratio is, they might not know. A lot of times IT is the last person that knows what's going on with the workload. So you can use vCenter tools. We cover this actually in our installation guide for doing regular sizing. Use vCenter oftentimes is a good way to figure out peak IOPS and also get a feel for the read-write ratio. Because remember, our replication is coming from the changes or the writes that are going to storage on site. So that's the explanation of these columns. Once you have this, then you can use that write percentage at peak, and that'll give you a feel of the megabytes per second that would be flowing into an instance on AWS. I saw some questions on faces. Oh, okay. You want to add some?
Yeah, so you were talking about once you get that. It starts also when you are looking at the limits on the AWS side too. That helps start dictating the architecture, as you'll see as we go along here, of we had to have more ZCAs because of certain conditions that we found in the worksheet. The architecture actually came from going through these numbers, and I know that's what you're about to talk about with the VPGs of how you broke them up.
So this is just an example. These aren't tied together, but keeping in mind to keep the fewest number of VMs that you need for consistency within a VPG, because as you exhaust an AWS instance, you want to have the flexibility to just snap on another VPG onto that instance if it's small, or fire up another ZCA instance and start snapping on VPGs to that. So that's why we laid it out this way, where you would have your target VPG, just number them, name them or something, take the VMs from the prior sheet. You might want to note the workload type, because as you start thinking about sets of VPGs to configure to AWS, you might want to keep that in mind and do maybe an FTP server or something non-critical earlier, or if you think a ZCA instance might be reaching exhaust, it might help to know the workload type. Then you would have your max IOPS. You would add that up for all of those VMs together, and then you would focus it on a ZCA. So then that way you can do a check on yourself. Am I just at peak time? Am I already outstripping the ZCA instance of what I've picked from AWS?
Yeah.
Make sense? Okay.
So the ZCA grouping, because I've seen you use X for the first two, is that just based on the performance of the IOPS, or is there another logic there as to why you're grouping those and then having separate ones for the third and fourth?
You hit it on the nose. So on this case, you can see the first VPG1 has 5,000 IOPS and perhaps maybe large block size. And I was forecasting that would probably exhaust that particular instance. And so then you'd have another instance. You might know that there's growth, and so you want to keep a ZCA ready to go, perhaps. But yes, that's why it's very critical to kind of know the nature of the workloads, the read-write ratio, the block size, so that you can stay ahead of that instance getting exhausted.
Yeah.
Okay, thank you.
Okay, so then on this case, this was a real life customer case. They showed us all their stuff. We started out with the earlier slide just showing the sites. Then we went and laid on their VRAs, and we had the VPGs and a spreadsheet. On this case, it was a customer between 100 and 120,000 IOPS, and so we figured we'd keep the ZCAs around 20,000 IOPS, which you'll see on the standard AWS instance is coming in around 20,000 IOPS if you have smallish block sizes. So on this case, the customer themselves said, I think maybe 6 would be a good number, keeping in mind the instance sizes, and then looking at the workloads really that was going on. So they had 18 VRAs at one site, and they had 3 VRAs at another site, and they spread them out among the ZCAs.
Yeah, and they're using that deployment process that we've talked about. So they're starting, because they've got multiple VPGs that they deployed first, they're getting this initial in place, they're measuring, and then they could do several things. Like you said, we support multiple instance sizes for the ZCA that we've tested. You know, you mentioned one that's very, very large that we haven't tested. In theory, it should work. I mean, it's a Windows VM. But that's the reason why we support multiple sizes already, because you may have those ZCAs laid out, and you may need to upsize 1 or 2 of them to better perform for burst or whatever kind of workload that's going on at the time. So it gives you a lot more flexibility because you've laid it out pretty well first, but then you can start tuning and tweaking with like instance sizes of the ZCAs and really start dialing in the environment as it gets settled into going to AWS.
Also, going this way, you can also estimate what your monthly budget would need to be for those instances.
Yeah.
So then you would configure your first VPG. It might be a set of VPGs depending on how you've laid things out, but go configure that, wait for the initial sync to finish, monitor what's going on the network, then do your failover test. Then you would configure the rest. So some of the things we recommend: monitor the initial sync to completion. It could take a little bit longer than you're used to. Monitor the bandwidth. You can monitor it both on the AWS side as well as on our side, or you have networking tools, you can monitor it. Then again, you could do the failover test after the initial sync's finished. Then once you do that initial sync, another couple of tips we have is monitor the ZCA CPU performance. That's pretty key to let you know you might be exhausting it besides on the networking side of things. So if you're running at 80% CPU utilization for an extended period of time, then it's time to either go to a larger ZCA or think about deploying a new instance if you want to keep them all the same. If you see your RTO trending over 2 hours over time, that also means you're going to need to either scale out or scale up, either reduce the journal size, put a new ZCA in, or get a bigger instance of ZCA of what you're running. So those are the kind of things to kind of keep your finger on as you're running. A couple other best practices we've gathered up. Our default instance size, if you get this from the marketplace, is an M4 extra large. We've also tested the ones here, and we've deployed that with a customer. We recommend, if you think your instance size is not appropriate, that you contact our support, especially if you're going off of one of these instances here. We would like to note it in your case so that if you have issues later on, we know what's going on. Then we already talked about fewer VMs per VPG, so you can mix and match and snap them onto different CCAs easily. See, Be ready. Oh, the other reason for monitoring is to be ready to add a new ZCA instance if needed, or else upside the instances that you're on. And the other key thing to keep in mind, and maybe you made this point very well yesterday, around planning for the CPUs you're going to need for a failover, because we're going to create those VMs on a failover, and they're coming out of your AWS storage account. So there, I don't recall what the default is.
Yeah, so the core count. So what you can do is go ahead and request, if you guys are running, you probably had to request more cores in certain machine sizes, because what's it, 20 for AWS core? So you can exceed that rather quickly when you're doing failover testing or failover when the machines are coming up. So you can request from them to just have more cores available to you. I think they go up to like 150, 200 before you have to get like POs and stuff involved.
So that's another thing to think about when, and so if you might have noticed on the prior slide, we did recommend that you note down the number of CPUs for those VMs, because for every ZCA instance, you got to be sure that you've got that number of cores in your account, or you'll have to wait and go open a ticket with AWS, get more cores added to your account before you could do a successful failover, or failover test for that matter.
Yeah.
So those were our main best practices we've collected. So the summary is there's a ton of benefits of going to the public cloud with Zerto, both for migration or for data protection. Be aware of some of these differences so you'll be successful right out of the chute. And then we recommend you take the plan first, do a small VPG or set of VPGs, monitor it, then do the rest of your VPGs as you deploy and as you grow your installation.
Very good. Any questions?
On the encryption side, when we're restoring servers in AWS, we're having to convert the drives after we put them in AWS to encrypted volumes. Are you guys going to have that as a default?
That's on our roadmap to be able to encrypt data at rest on AWS. It'll most likely be early next year. We're scoping and planning for it right now. We've had a number of requests, so it's very high on our priority list.
Thank you.
Any other questions? All right, end of show.
Thank you.
Thanks, everybody.
Now we finished.